Hello guys, welcome to Jocademy. Today we'll be reviewing chain rule, implicit differentiation, and applied application, or whatever it's called. Anyways, this video was sponsored by Alan, and of course Matthew Kaung. Don't they look similar? Why do they look similar? Anyways, these two said make a Joe Gaming video on chain rule, so I'll make one. But also, I already taught chain rule. So this is just gonna be a short chain rule review, and we're gonna go to implicit and apply the Sdigmas. Alright. So from my last other Joe game, I told you about 3 thin x squared plus 3 cubed. I told you to Matt Kwong over here to go solve it. I have not seen him solve it yet, and so I'll be here to teach you how to solve it. So, with any, hold on. Like I showed you last time, this thing. Alright, from here, I showed you this thing. And let's just say we got a constant here, right here. We got a constant. We got a power roll right here. We got a trig function, and we got another function that uses power roll. So let's write, for those who don't see the answer already, let's just write out our functions. We got 6 times, let's say, u cubed, where u equals sin of x. And you know what? U can be a function. Let's say this is, let's say u is f of x. F of x equals 6u cubed. And then, you know, this right here, but then you'll realize, what if I change this into g of x? Oh my god. And then this inner function right here, it's called it's called like a of x equals x squared plus 3. And then you'll realize this. Watch. When we sub in these, let's say this x right here, then we can put it as like b or some random amount of letter. Maybe you can y, change it to y or something like that. Then y equals and then if you write out the actual equation, it would be f of x equals 6 times f of g of a of x cubed. Oh my god. Isn't that scary, chat? Now, we want to get derivative. We're gonna use some chain rule. So let's start out with the chain. Okay. So, let's start with the first function. Let's f prime x is just use the chain rule. So look at this. The 3 from here goes here times 3 and then minus 1. So then we get we got 18 u squared, right? Sub in, and then we're gonna sub in u for g of x or whatever for sin. So then we get f prime x equals 18 sin of y squared. Oh, scary, huh? And then if you see chain rule, it's multiplied by the derivative. So you multiply by cosine y. But I saw Alan. You replace the sin squared with cosine squared, but you don't do that. It's a multiply. It's a multiply, and you keep the squared on the sin, okay? And you also keep the y here too. And then guess what? Guess what, Chad? Guess what? The derivative of g of x, but g of x has a function in it, so you have to do it again, and the function is here. So I'll put in y, write out y, f prime x equals 18 sin x squared plus 3 squared times cosine x squared plus 3. Okay? And then we multiply it by the derivative of this, which is just 2x. Sdigma, what the 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 Sdigma, and then if you simplify, it's just 32x. So to recap, using the chain rule, we can see that first f of x is to x to the n power type function, use power rule, and then you still keep the sin function inside because of chain rule, but then you multiply that function by sine's derivative, which is cosine, right? And then you realize that cosine also has a function in it. So you do the thing again, but since cosine is already a derivative, you ignore this part and just multiply it by the derivative inside. Just x squared plus 3 turns into 2x. Oh, bang! Just like that. Okay. Those who know will know. To sum it up, basically, if there's ever a function like this, hold on, if there's ever a chain rule like this, like that, and you can go like a million quadrillion functions down the road. but let's just say for this specific example, the chain rule for this would be f prime g of x times g prime a of x. Wait, hold on. There you go. Times g prime a of x times a prime of x. You understand now? Do you understand? You go. You get rid of the outside variable for every function, turn it into a derivative, and then you take out this one, take the derivative, and then you keep going. You know what I'm saying? Okay, let's do one more. Okay, we're back. I got a function, those who know. So let's get the function cosine square root of sin tan of x. Now let's find our functions. Let's see where the function's at. So biggest function, the one that is foremost, is cosine. So f of x equals cosine u, where u equals g of x, where that is also equal to the square root of, let's say, L. Yeah. And then L is equal to a of x, which is sine of y, let's say that, where y equals b of x, where that is equal to tan x. So in total, we have 1, 2, 3, 4 functions. I'll give you a second to do this. Think about it. Seconds up. Alright. So, look at the chain rule. F of x, g of x means f prime, g of x, g prime x. So, basically, derivative of cosine is negative sine. And the inside function u, or g of x, is square root L. And L is the a of x, which is sine of y. Y is equal to tan of x. Tan of x. And then we're gonna multiply by g prime x. G prime x is square root L. Derivative of a square root is 1 over 2 square root, and then the inside, which is L, which is sine y, and where y is that, so sin tangent x multiply, and we're back to here again, back to here, but we already got our f prime g of x right here, so all we have to do is multiply by g prime x, which in this case would now just be the lower level. Let's just number these 1, 2, 3, 4. Each level goes down, down, down. So next level, sine y, or sine tan x. The derivative of sine is cosine, so cosine of tan x. And then we got here multiplied by the derivative of tan, which is just secant squared x. And since x derivative is just 1 times 1, that's nothing. So yeah, there you go. Notice how this function has the most functions in it, and every time we go and do the chain rule, it's less and less functions inside the function. We keep doing chain rule until we have only x inside the function, until the last derivative. And you don't carry on certain attributes from it. Yeah. Start with sigma, end with alpha. Think about it.
I have to finish writing this paper. I'm swamped.
Just get Grammarly. It's free.
Can it help with what I wrote last night?
Grammarly will catch all those spelling and grammar errors, and it'll help with the bigger stuff. Grammarly can also give you ideas to make your writing better. Add more background, add specific examples, focus your conclusion.
This sounds like me, but better. A less damp me. You think a less damp me could get that internship?
A less damp you can do anything. Download Grammarly for free.
Only the one who has earned the people's support is fit to be king.
Charging!
Okay. Those who know will know. Alright, those who know will really know. So, we got an implicit differentiation problem here. If you're not Alan, then you can stay. Or if you are Alan, you could stay. But at this point, you're probably not going to learn this until later. Anyway, so how do you solve this? Given dy dx, you have to find dy dx. Well, I'll tell you what. You get the derivative of both sides. Watch. So C derivative is negative CSC x times cos x. And that's equal to the product rule of this, because this is one thing, that's one other thing. So the product rule, that's just 1 plus tan y times it's times secant squared y times dy dx and also next one. And then what you're supposed to do, wait, this is an I, my bad. What you're supposed to do is take this to the other side and then divide it by secant squared. Oh, why? Why so serious? Why so serious? So serious. sorry. And the reason why you do dy dx on y is because if you do the chain rule on the x's, you get dx over dx for CSC when you initially derive it, and it'll just cancel out to 1. And since dy is different from dx, it doesn't cancel, and you do it to the y because you have to put what's inside the function on the top of the d when you get d over dx. You have to multiply by the variable inside the function, which in this case dy dx. And since if you multiply it by x, it cancels. And to prove my point further, if you had an equation like y equals x squared, you'd probably get the derivative like this. But another way to write it is dy dx equals 2x. And where you got dy dx is because you d over dx both sides, where x's cancel out and that y carries on. Get rid of that 1. Y because it turns to 1. And yeah, that is what this is. No further explanation needed for now. It's pretty simple. Just as long the rule is when you're deriving by some variable, if it's x, then you put the variable of the function inside here, y. If it's a d over dx and there's a y, just put dy dx of the derivative of the y function. Yeah, if it was dy dx, it would be negative CSC x cot x equals d over dx, the dx over dy, 1 plus blah 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 blah, you know all that, all that. You get the point, I think. Now to related rates. Okay, so I'll be doing like 4 of these. So let's do this one. I haven't done it yet, so I'll be learning too. A trough is 12 feet long. Right here, this is long, and 3 feet across from the top. So it's what? Across the top, So this is 3 feet. It ends are isosceles triangles with altitudes 3. What? You're saying this is 3 feet too? Who knows? Who knows? Water is pumped into the trough at 2 cubic. So basically it's saying dv over dt equals 2 cubic feet per minute. Or yeah. And it's dv over dt because it's filling the volume of the trough. So the speed of the trough is 2 feet. Yeah. Now fills water got a depth of 1 foot. So at whatever this is, I would assume I'm gonna assume that this and this are the same, as in the same, they're pointing for the same variables. Okay, I searched it up. The volume of the thing is 1/2 BHL, where L is this 12 feet, B is the 3 foot, and the height is, 3 foot. So it's basically this triangle, which is the base 3 feet, height 3 feet, times this 12 foot, those who know. So how fast is it pumping? Wait, no, how fast is the water rising? So if it's asking for rise, then that would mean it's the height. We're trying to find the height. So dv over dt equals 1/2. Now let's think about what the other variables B and L
Meet
are.
Cheryl. Hey. She's on vacation and lost in the moment. Unfortunately, so is her Chase debit card.
It's gotta be somewhere.
Maybe she lost it at salsa night.
These skirts should have pockets.
Or maybe she lost it at Pilates.
3 and 2 and...
But she's not worried. With the Chase mobile app, she can lock her card till it turns up. Tools that help protect. One bank that puts you in control. Visit chase.com/checking. Chase, make more of what's yours.
Chase mobile app is available for select mobile devices. Message and data rates may apply. JP Morgan Chase Bank, N.A. member FDIC.
Okay, hold on. It says depth H is 1 foot, but it says level rising. So that is interesting. Hard part about these questions is understanding what you're trying to get. You can make an argument that the length is always going to be the same. So L is constant. That leaves with B and H. Let's see if B is constant. The base right here. Well, I mean it's smaller here. And H, well, it's clearly changing too. The only thing that's not changing is the length. So, could one assume that since it's an isosceles triangle, that the ratio between the length and the height are the same still? Meaning that at h 1 foot, it also means that the base is also 1 foot too at this moment. But B also be 1 if H is 1. Because it's an isosceles. Who knows? Who knows?
Shopify helps you sell at every stage of your business. Sell it online, take it in person, and go big, like 1 million orders big. Whatever your stage, businesses that grow with Shopify. Sign up today at shopify.com/YouTube audio.
Okay, so could I also assume this is a square and therefore this hypotenuse is 12? And so this triangle and this triangle here. Is there a way to prove that the rise of this is equal to the increase of the base is equal to the increase of the heights? Who knows? Okay, I watched the African guy explain it to me. So basically, I was kinda right. These two are equal, so therefore the new equation should be substitute L for 12. 12 half is 6. And H is equal to B no matter what height, because it's related. So it's more or less H squared. Yeah. So dV over dt equals 6 2h, which is just 12. 12h dh over dt. And substitute dv over dt, which is 2. So 2 equal 2 divided by 12h, which is just 1/6. 1/6h, so 1h over 6 equals dh over dt. And since we're given that h is 1 foot, it is just 1/6. So dh over dt is 1/6 feet ft cubed per minute. That is the answer for A. Now, let's do B. The water is rising at a rate of 3 over 8 inches per minute when h equals 2. Determine at which the rate is being pumped into the trough. So now we have to find dv over dt, given that dh over dt equals 3 over 8 at h equals 2. So this equation stands no matter what. So basically we're solving for dv over dt, which is just use this equation and plug in the knowns, which is 2 and 3/8, and you get dv over dt. So let's just do that. So that's h for that is 24 times 3 over 8. So that's just 8 divided by this. It's just 3 times 3 equals 9 feet cubed per minute. dv over dt equals 9 feet cubed per minute. That's just basic algebra. Okay. Next problem. Okay, I like this problem. It's pretty Sdigma. Should I make that thing? Okay. So, a winch right here. This is a winch. 12 feet tall building. So this entire building is 12 foot. Pulls a pipe. This pipe with the same length, which means the hypotenuse is 12 and it's constant. As shown in the figure, the winch pulls at negative 0.2, so it's pulling inwards at negative 0.2 meters per second on the vertical rate and the horizontal rate of the pipe. So as the winch pulls at 0.2 per second, ds over dt, so it's pulling this way, it's pulling at the hypotenuse this way. So the first thing we're gonna do, and it's asking the change the speed of the height and x at height equals 6, so right here, realistically it would be here. So it's asking for when the hypotenuse or this rod is at 6. So it would more or less look like this. Like the rod would look like that. Hold on, let me draw it better. So just extend it out and make this intersect with this. So yes, so the triangle will look something like that. So this triangle, okay, so right, this is the winch, this is the pipe, and so given this, we are also given that the height is 6 for the rod, and since this building is 12 foot, it should be 12 minus 1. Well, actually, no, don't. 6. This is y, which is 6, y equals 6. And this is 12 minus y because we don't know exactly. I mean, if we're being more general for equation, it should be 12 minus y. And this part, this thing is just x, they both share an x. And if you see something, if you plugged in 6 for y, you'd realize, so let's just write the Pythagoras for both of them. So 12 squared equals y squared plus x squared, and s squared equals 12 minus y squared plus x squared. Plug in 6 for y, 12 minus 6 is 6 squared, and then this is 6 squared plus x squared. That means therefore s equals 12 at when y equals 6. S isn't always equal to the rod, but only when y equals 6 at the moment. So we're given this automatically. And let's start solving for y first. So yeah, let's go with this one first. 0 equals 2y dy dt plus 2x dx dt. We are given none of these so far, so let's use this other equation. 2s ds dt, we are given that, equals, now 2 times 12 minus y dy dt plus 2x ds dx dt. And we can plug in I mean, actually, you can divide these 2's automatically. Also get rid of those 2's too. So now it's just s equals 12 minus y dy dt, blah blah blah. If we're solving for dy dt, I mean, you can plug in y right now, and we can probably do something like that. We don't know any of these right now. So realistically, let's go to the second equation and solve for a variable because there's only 2 of them. So if we're solving for dy dt, it would be dy dt equals negative dx dtx. And why don't we plug in x dx over dt first? So dx dt equals negative y over x dy dt. Okay, I don't want to explain or write this again. I spent like 20-30 minutes doing this, like trolling. So a winch at a 12-meter building pulls a pipe. So the triangle would look like this right here. This is the winch, and this is the pipe. The height between the winch at the edge of the pipe is 12 minus y. The height of the pipe is y, and they share an x value. So yeah, and they're all right triangles. So you can write Pythagoras right here. This is Pythagoras right here, and you'll realize that if you plug in 6 for y, you'll realize s equals 12, and so we'll find the derivative of both equations, like this one, but we're negative here. It's negative. So now that you're up to date what I'm doing, we don't know dy dx, we don't know dx over dt, we know ds over dt and 2 ns. So just solve for dx dt in this equation, where cancel out these 2's, where dx over dt equals negative y over x dy dt. And if you plugged it in for dx over dt over here, the x on the bottom of this and this x on top would cancel out, and it would be dy dt. And if you plugged in 6 for this, it would be negative 6 minus 6 dx dt, which is negative 12. So we got negative 12 dy dt equal to s ds dt, which is 12, times negative 0.2, which is negative 1/5.
You want to
Divide
career in
12 and you
cybersecurity.
get rid of
We
the
can help you
negative
get
12,
there.
and the
Our
answer is
stackable
1/5
cybersecurity programs
dy
offer the flexibility
dt.
to earn a higher degree at your own
Yeah.
pace. Advance your ambition in cybersecurity
vertically-
at devry.edu.
Vertically,
This
I mean,
duo hydrates,
horizontally,
brightens,
I
and
mean,
repairs the
all you have
skin
to do
barrier.
is
Hyaluronic
plug
acid
in
formula
this
instantly hydrates and
values.
plumps your skin. Apply it first, then
So
use
if you
niacinamide
wanna
to target
find
dullness and
X,
textural irregularities. You
just
can use
use
these 2
this
serums every
formula,
day and night for smoother,
and you'll
healthier
realize
skin.
that 12 squared minus 6 squared square root equals square root 108. And if you plug in those values for this here, where dy dt is 1/5, where I write this right here, 1/5 times 6 times square root, under square root 108. That is your answer right there. Boom. Actually, I think it's negative. So yeah, there you go. That's the answer. 6/5 square root 108, and you get the real answer by putting the square root 108 on top of the fraction. Okay, last problem. I can't do this no more. We're doing the baseball one. Okay. A baseball has a diamond, a square with 90 feet. Seen a figure. So yeah, this is 90 feet long. The player is running from second base. So on second base to third base. So we're going here, and the speed is 25. So the speed of the person would be going 25 meters or feet per second going this way, and it's 20 feet from the base, so like right here, let's say about 20 feet away. So you'd probably get like, it'd probably be like 90 minus 20 minus the distance equals, you know, 7 equals 20, which is this distance. But let's just keep it at 20 for now. And let's say this is y, or yeah, let's just say that's y. And this is x. And what is the distance from the home plate? Changing, how is it changing? So we basically got this. So this person's running and the hypotenuse is changing. Y equals 20 at this moment. Yeah, y equals 20 at the moment. Because we can make a triangle like this. I mean, you could just make a bigger triangle like that and do like some random x minus whatever, but I don't want to do that. So yeah. Y equals 20, and we can use the hypotenuse. So 20 squared plus 90 squared equals, let's see, the hypotenuse is h squared. We can find the hypotenuse right now. 20 squared. Yeah, so it's 700 square root h equals, I'm not gonna show you the math. Wait, no. It's 8,500. Okay. I'm not gonna show you the math on that one. Okay, so just get the derivative. So the only thing that's changing is the hypotenuse and the person running from second to third. So the only thing that is not changing is third to home base. It's always gonna stay at 90 feet. So we just write it as 2h dh over dt equals this, okay, dy dt, or 2 dy dt. There you go, and you just cancel the 2 out. And dy dt, well, it's just h over y, dh dt equals dy dt. Oh, whoops, my bad. Find that change in the hypotenuse, right? Yeah, so it should be y over h dy dt. And so just plug in your knowns, which is 20 over 8,500 times 20 feet. It's actually negative, by the way, too, because you're decreasing your distance as you're going in. So yeah, and yeah, 25 feet per second. So whatever this value is, so 25 times 20 is 500 over square root 8, 500, which probably could find something. 500 divided by 500 is 17, so square root 8 500 over 17 is your answer. Yeah. No more. Wait, I need to check my answer. Oh my god. Oh. Okay, well, the answer is this, and if you put in the calculator, it is right. They did not get rid of the square root on the bottom, so whatever. Yeah. Kawapanga. Okay, I don't want to explain or write this again. I spent like 20-30 minutes doing this, like trolling. So a winch at a 12-meter building pulls a pipe right here. At a vertical position as shown in the figure, the wind pulls at -0.2 meters per second. Find the rate of vertical change, the speed. Yeah, just find the speed of the y and x of the pipe when y equals 6. So the triangle would look like this right here. This is the winch, and this is the pipe. The height between the winch at the edge of the pipe is 12 minus y. The height of the pipe is y. And they share an x value. So, yeah. And they're all right triangles. So you can write Pythagoras right here. This is Pythagoras. Right here. And you'll realize that if you plug in 6 for y, you'll realize s equals 12. And so we'll find the derivative of both equations, like this one. But we're negative here. It's negative. So now that you're up to date what I'm doing. We don't know dy dx, we don't know dx over dt, we know ds over dt and 2 ms. So just solve for dx dt in this equation where cancel out these 2's, where dx over dt equals -y over x dy dt. And if you plugged it in for dx over dt over here, the x on the bottom of this and this x on top would cancel out, and it would be dy dt. And if you plugged in 6 for this, it would be -6 minus 6 dx dt, which is -12. So we got -12 dy dt equal to s ds dt, which is 12, times -0.2, which is -1/5.
You want to
Divide
career in
12 and you
cybersecurity.
get rid of
We
the
can help you get there.
-12, and the
Our
answer is
stackable
1/5
cybersecurity
for
programs
dy
offer the flexibility
dt.
to earn a higher degree at your own
Yeah.
pace. Advance your ambition in cybersecurity
vertically-
at devry.edu.
Vertically,
This
I mean,
duo hydrates,
horizontally,
brightens,
I
and
mean,
repairs the
all you
skin
have to do
barrier.
is
Hyaluronic
plug
acid
in
formula
this
instantly hydrates and
values.
plumps your skin. Apply it first, then
so
use
if you
niacinamide
wanna
to target
find
dullness and
X,
textural irregularities. You
just
can use
use
these 2
this
serums every
formula,
day and night for smoother,
and you'll
healthier skin.
realize that 12 squared minus 6 squared square root equals square root 108. And if you plug in those values for this here, where dy dt is 1/5, where I write this right here, 1/5 times 6 times square root, under square root 108. That is your answer right there. Boom. Actually, I think it's negative. So yeah, there you go. That's the answer. 6/5 times square root 108, and you get the real answer by putting the square root 108 on top of the fraction. Okay, last problem. I can't do this no more. we're doing the baseball one. Okay. A baseball has a diamond, a square with 90 feet. Seen a figure. So yeah, this is 90 feet long. The player is running from second base, so on second base to third base, so we're going here. And the speed is 25, so the speed of the person would be going 25 meters feet per second going this way, and it's 20 feet from the base, so like right here, let's say about 20 feet away. So you'd probably get like, it'd probably be like 90 minus 20 minus the distance equals, you know, 7 equals 20, which is this distance. But let's just keep it at 20 for now. And let's say this is Y, or yeah, let's just say that's Y. And this is X. And what is the distance from the home plate? Changing, how is it changing? So we basically got this. So this person's running and the hypotenuse is changing. Y equals 20 at this moment. Yeah, Y equals 20 at the moment. Because we can make a triangle like this. I mean, you could just make a bigger triangle like that and do like some random X minus whatever, but I don't want to do that. So yeah. Y equals 20, and we can use the hypotenuse. So 20 squared plus 90 squared equals, let's see, the hypotenuse is h squared. We can find the hypotenuse right now. 20 squared. Yeah, so it's 700 square root h equals, I'm not gonna show you the math. Wait, no. It's 8,500. Okay. I'm not gonna show you the math on that one. Okay, so just get the derivative. So the only thing that's changing is the hypotenuse and the person running from second to third. So the only thing that is not changing is third to home base. It's always gonna stay at 90 feet. So we just write it as 2h dh over dt equals this, okay, dy dt, or 2 dy dt. There you go, and you just cancel the 2 out. And dy dt, well, it's just h over y, dh dt equals dy dt. Oh, whoops, my bad. Find that change in the hypotenuse, right? Yeah, so it should be y over h, dy dt. And so just plug in your knowns, which is 20 over 8,500 times 20 feet. And it's actually negative, by the way, too, because you're decreasing your distance as you're going in. So yeah, and yeah, 25 feet per second. So whatever this value is, so 25 times 20 is 500 over square root 8, 500, which probably could find something. 8,500 divided by 500 is 17, so square root A500 over 17 is your answer. Yeah. No more. Wait, I need to check my answer. Oh my god. Oh my god. Okay, well the answer is this, and if you put in the calculator, it is right. They did not get rid of the square root on the bottom, so whatever. Yeah. Kawapanga.